Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today, word subsets, Leetcode 916. In this problem, we are given two string arrays, words 1 and words 2, and a string B is subset of string A if every letter in B occurs in A, including multiplicity. For example, if B is WRR and A is warrior, then B is subset of A because we want W and two R's in warrior and we can find them. And even though here we can see that order of characters in B and A is same, but in reality for subsets, the ordering of the characters don't matter. And what is crucial is that all characters of B must be present in A and A must have at least as many occurrences of each character as B. Additional characters in A do not matter. For example, here we have an extra R, which is okay, and WRR is still the subset of warrior. Then they say string A from words 1 is universal if for every string B in words 2, B is a subset of A. So what they are saying is given word in words 1 is called universal if all the words in words 2 are subset of that word. In the end, we should return an array of universal strings in words 1 and we can return it in any order. Then in example 1, first word in words 1 is amazing and we can see that E is not present in amazing. So this is not a universal word. Then we see apple and apple has E but it doesn't have O. So this is also not a universal string. Then we see Facebook. Facebook does have E as well as O. So this is a universal string. Then we see Google. Google has E as well as O. So this is also a universal string. And finally Leetcode also has E as well as O. So this is also a universal string. So our answer will be Facebook, Google and Leetcode. And also in terms of constraints, words 1 and words 2 consist only of lowercase English letters. And all strings of words 1 are unique. Now in terms of solution, one of the naive approach can be to iterate over every word A in words 1 and check it against each word B in words 2. And if at any point we found out that word B is not a subset of word A, we will skip the word A. Otherwise, if all the words in words 2 are subset of word A, then we will add A to the list of universal strings. For example, for the given input, first word in words 1 is amazing and we will try to match it with all the words in words 2. And first word in words 2 is AC. And we can see that A is present in amazing but C is not. So because of that, amazing is not a universal word. So we will skip it. And then for Coca-Cola, we can see words AC, OC and COO are all subsets of it. So we will add Coca-Cola to our answer list. And similarly, we will continue with the rest of the words in words 1 and match it with all the words in words 2. And now the question is, how can we check if word B is subset of word A? And one way can be, since multiplicity matters and we are doing the continuous lookups of characters of B in A, we can create a frequency map for both the words A and B and match the frequencies. That is, for each character in B, the frequency in A should be at least as much as that in B. For example, if word A is Coca-Cola and word B is COO, then frequency map of Coca-Cola will be C occurs thrice, O occurs twice, A occurs twice and L occurs once. And frequency map of COO will be C occurs once and O occurs twice. And now to check if B is subset of A, we will start matching the frequencies of characters in B with those in A. So the first character in B, that is COO, is C with frequency as 1, which is less than the frequency of C in Coca-Cola, which is 3. Therefore, character C will be sufficiently covered. Then the next character in B is O, which has frequency 2, that matches with the frequency of O in Coca-Cola. So as all the characters in B are present in A with the required frequency, COO is indeed a subset of Coca-Cola. Similarly, let's take word A as amazing and word B again as COO. Then frequency map for amazing will be A occurs twice, M occurs once, Z occurs once, O occurs once and N occurs once. So again we will check if B is subset of A. So first character in B is C and its frequency is 1. But the character C does not exist in amazing. That is, its frequency is 0. So B is not subset of A. So in summary, we will iterate through all the words in words 1 and check it against each word in words 2 by building the frequency map and comparing the frequencies. And if all the words in words 2 are subset of a word in word 1, we will add it to the list of universal strings. Now the time complexity of this approach will be O of M into N for these two nested loops where M is number of strings in words 1 and N is number of strings in words 2. And then for each word we are creating a frequency map which will be proportional to the average length of words in words 1 and words 2. So overall time complexity will be O of m into n into average length of strings in words 1 and average length of strings in words 2. And the space complexity will be O of 1 for storing the frequency map of 26 lowercase English letters. And now the question is, how can we do better? The bottleneck in the brute force approach comes from repeatedly checking the characters of all words in words 2 against each word in words 1. So how can we optimize it? Now we know that we need to go through each word in words 1 and check if they are universal or not. So we cannot avoid this outer loop. Also, for checking the subset, order of the characters don't matter. And word A in words 1 is considered universal if all words in words 2 are subset of it. Therefore, we can create a combined frequency map of all words in words 2 to simplify this check. For example, if words 2 have words like AB and CD, then the merged frequency map will look like this. And then for each word in words 1, we can just refer to this merged map and get rid of the inner loop iterating through words 2. But now the question is, what should we do in case words in words 2 contain common character? For example, consider the words AC and OC, which have C as a common character. So what should be our merged frequency map now? It should be A one time, O once, and C also one time, because we need to satisfy the subset condition for each individual word in words 2, right? But consider the character O, which is common between OC and CO. Here, we can see that O occurs once in OC but twice in CO. Now, what should be the frequency of O in combined frequency map? Should it be 1 or should it be 2? And the answer is it should be 2. For example, if you would have taken the frequency of O as 1, then even if OC would have been satisfied, say in Leetcode, but CO will not. So we always take a maximum frequency in the combined frequency map in case we have a common character between words in words 2. This ensures that a word A in words 1 can then meet the highest individual requirement for each character across all words in words 2. So now our task is simple. First we build the max frequency map for each word in words 2, and then for each word A in words 1, we just need to check if it satisfies this merged frequency map created from words 2. And if it does, we will add it to the list of universal strings. And now, since we only have lowercase English letters, instead of using a frequency map, we can also use an array of size 26, where 0th position maps to character A, first position maps to character B, and so on. And we can store the frequency of respective letters according to their position in the alphabets. So for example, for words 2, we can make a common frequency map. Let's call it B max. So we will have characters A, B, C, O, and so on with their positions 0, 1, 2, and O is 15 characters. So in 0 index array, it will be 14 and so on. And now we will go through each word in words 2 and build this combined frequency array. Initially, all the values in the array will be 0. And then first word in words 2 we see is AC. So we will set the frequency of A and C to 1. Then we see word OC. So we set the frequency of O to 1 and frequency of C remains 1. Then we see CO, and here frequency of C is 1 and O is 2. So again frequency of C stays 1, but we set the frequency of O to 2, which is a higher frequency. And now we are done with all the words in words 2. And now we will go through each word in words 1, build their frequency map. And now instead of comparing all the words in words 2, we will be just comparing the combined frequency map of words 2. And in the end, we will get our answer as Coca-Cola and Facebook, because those are the two words which have at least one A, one C, and two O's. And now given M as number of words in words 1 and N as number of words in words 2, the time complexity for building this max frequency map will be O of N into average length of words in words 2. And then we will go through each word in words 1 and build the frequency map. That will take O of M into average length of words in words 1. And then we are comparing those frequency map. And note that we have only 26 characters in both the frequency map. So it will be O of 26 or O of 1, that is constant. But we are doing it for each word. So overall time complexity now becomes O of N into average length of words in words 2 plus O of M into average length of words in words 1. And the space complexity says O of 1 because we are using these 26 characters frequency maps. So now let's jump into the code part. First let's initialize the array Bmax, which will store combined maximum frequency of each word in words 2. Now we will iterate through each word in words 2 and count the frequency of each character in current word using the helper function count. Now let's define this helper function. First, let's initialize the array of size 26 to store frequencies, as we are only dealing with lowercase English letters. Now we will iterate through each character in the word and increment the frequency at the corresponding index, and we will get the index by subtracting the ASCII value A from the character. So for A we will get index 0, for B we will get index 1, and so on. And once we are done with all the characters, we will return the frequency array. And now coming back to our calling function, once we have the frequency array, for current word B, we will go through frequency of each character in the current word and update the maximum frequency of the character in the Bmax array. This ensures Bmax stores the maximum frequency seen for each character across all strings in words 2. And once we have the combined frequency map of words 2 in Bmax, we will initialize an answer to store the universal words. And now we will go through each word in words 1 and count the frequency of each character in the current word using count helper function. And now we will check if current word's frequency is superset of Bmax using this is subset helper function. If it is, then we will add current word to our answer list. And once we are done with all the words in words 1, we will return our answer. Now let's also define our is subset function. So is subset function takes in two frequency maps and check if B is subset of A or if A is superset of B. So for that we will iterate through each character index and check if A has fewer characters than required by Bmax. If character requirement is not met, we will return false. Otherwise, if all the character requirements are met, we will return true. Now let's submit this code. Awesome. So that's all for this video. Today we invested more time on the brute force side of things, but I hope that was worth it and this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.